Good day everyone, I'm Rafaela T Galdones and I'm the first reporter of Part 3, Introduction to Electronics. Normally, bipolar junction transistor, diodes, and field effect transistor are commonly used electronics component and electronic circuit. So, bipolar junction transistor is a type of transistor that uses both electrons and holes as a charge carries, diodes as to limit voltage loss, resistor in cases of high negative output current. Field effect transistor is a type of transistor that uses an electric field to control the flow of current in semiconductor. These components are interconnected along with required resistor and capacitor to form an electronic circuit. So what is the difference of resistor and capacitor? A resistor is an electronics component used to resist the flow of current in circuit. A capacitor, on the other hand, is an electronics component used to store electrical charge. Discrete circuit is constructed of components which are manufactured separately. Story of integrated circuit. This technology was invented in the year of 1950 by Jack Kelvy and Robert Noyce. So, kilalanin natin ngayon kung sino nga bang dalawang ito. Jack Kelvy was an American electrical engineer who took part along with Robert Noyce and the realization of first integrated circuit while working at the Texas Instruments in 1958. He was awarded the Nobel Prize in Physics on December 10, 2000. Robert Noyce was an American engineer and co-inventor of the integrated circuit, a system of interconnection transistor and a single silicon microchip. He made a massive impact on the field of computing in varieties of ways. The model of Kelvy is made up by germanium and Robert is made up by silicon. We have two main types of integrated circuits, the digital integrated circuit and analog integrated circuit. Analog integrated circuit involves an output signals that follow a continuous input signals in the initial stage known as input stage. The voltage or signal is received from a source. Digital integrated circuit is the basic building block from which all digital electronic circuit and microprocessor-based systems are constructed. From basic digital logic gate perform logical operation of AND or a NOT on binary numbers. 5. Integration. Small scale integration where the number of transistors incorporated in a single integrated circuit chip is up to 100. The second is medium scale integrated, where the number of transistors is incorporated in a single IC integrated chip is from 100 to 1000. Third is large scale integration, where the number of transistors incorporated in a single integrated circuit chip is to 1000 to 20,000. And fourth is very large scale integration, where the number of transistors incorporated in a single integrated circuit chip is from 20,000 to 1 million. And the fifth is ultra large scale integration, where the number of transistors incorporated in a single integrated circuit chip is from 1 million to 10 million. So we have two types of integrated circuit manufacturing technology. One is monolithic technology and other is hybrid technology. Monolithic constructed on a single piece of silicon or other semiconductor, then enclosed in a package with connecting leads. A hybrid technology is circuit of 10 ceramic substrate carrying one or more silicon chip. So that is the advantages and disadvantages of integrated circuit. William Shockley headed a team at Bell Telephone Laboratories that studied semiconductor and invented the transistor, and also he suggests electrical current could be increased or amplified using semiconductor and metals. William, known for point contact transistor, was the first type of transistor to be successfully demonstrated. The point contact transistor work a positive charge applied to the base of junction transistor causes electrons to rush from the emitter to the collector. Meanwhile, holes or positive charge travel to the ground. The voltage applied for the base determines the level of amplification and arrangement of junction direct to the flow of current.
So, amplifier. Amplifier are the tiny components in hearing aids that makes voices sounds louder. They also the gadgets and radios that boost faraway signals and the devices in stereo equipment that drive your loudspeakers and the huge black box you plug into, and that is to make them raise the roof. What are the amplifiers and how do they work? So next is amplifier is an electromagnetic or electronic component that boosts an electronic current. If you wear a hearing aid, you'll know it uses a microphone to pick up sounds from the world around you and convert them into a functioning electric current or a signal that constantly changes in strength. A transistor-based amplifier takes the signal and boosts it many times before feeding it into a tiny loudspeakers placed inside your ear canal, so you hear a much magnified version of the original sound. So, the easy bit of the amplifier is about it boosts an electric current, and the hand bit is that it must faithfully reproduce the quality of the input signal even when that signal is constantly and sometimes dramatically varying in both frequency and amplitude. For an audio
Hello, ma'am. I am Dianne A. Morillo, Bitilid Apa 1 student. So, my topic is all about the types of amplifier. So, before the types of amplifier, I just want to explain what is amplifier. So, amplifier is an electronic device that increases the voltage, current, or power of a signal. Amplifiers are used in wireless communications and broadcasting and in audio equipment of all kinds. They can be categorized as either weak signal amplifier or power amplifier. So now, let's come to the basic types of amplifier. So the first is voltage amplifier. So when you see voltage amplifier, this type of amplifier is designed to amplify a given to yield larger voltage output. So it involves low output impedance and high input impedance. So when we see low output impedance is desired such maximum current from the circuit. And when we see high input impedance, place very little load on a signals that is amplified to it. So the second types of amplifier is current amplifier. So this amplifier increases given input current. It is the opposite voltage amplifier in which it is characterized by high output impedance and low input impedance. So that is the current amplifier. So the third basic types of amplifier is trans-resistance amplifier. So when we see trans-resistance amplifier, it changes the output voltage conferring to the changing input current. So this type of amplifiers is also called as current to voltage converter. So it's a form of circuit that, as the name suggests, receives a current in amperes and converts it to the corresponding amount of the voltage. So the last basic types of amplifier is transconductance amplifiers. So when we see transconductance amplifier, it changes the output current according to the changing input voltage. So those are the basic types of amplifier. So the first basic types of amplifier is voltage amplifier. Second is the current amplifier. And the third is transresistance amplifier. And the last is the transconductance amplifier. So those are the basic types of amplifier. So like what I have said a while ago, that amplifiers, it involves the voltage, current, and power. So the main difference between a voltage amplifier and a current amplifier is voltage amplifiers amplifies the voltage, whereas the current amplifiers amplifies the current. So in the other words, we can say the voltage amplifiers provides higher voltage gain, whereas the current amplifiers provides higher current gain. So now, let's come to the amplifier class by the frequency. So amplifier class by frequency, it is the most important property of amplifiers. So in the frequency range that amplifiers have been designed for, they must deliver a constant and acceptable label gain. So the frequency response depends directly on the components and the architectures chosen for the designs of the amplifiers. So as you can see in the PowerPoint that we have the kilohertz. So when we see kilohertz, it is refers to how many thousands of cycles occurs per second, or it is used to measure frequency or cycle per second. And we have also the megahertz. So when we say megahertz, it is commonly used to express microprocessor clock speed. And also hertz. So when we say hertz, numbers of cycle per seconds. So that is the amplifier class by the frequency. So the next is amplifier classes A to D. So amplifier classes are little symbols applied to different power amplifier types. So the class gives a broad indications of an amplifier's characteristics and performance. So the classes are related to the periods that the active amplifier's device is passing current, expressed as a fractions of the period of a signal's waveform applied to the input. So Class A amplifiers is conducting through all the periods of the signals. Class B, only for one half the input period. Class C, for much less than half the input period. So Class D amplifiers operates its output device in a switching manners. The fractions of the time that the device is conducting is adjusted to a pulse, range modulations about obtained from the stage. So we have also the amplifier class by constructions. So by connecting the resistors across the input and the emitter terminals along with the resistor must also be connected across the output. So capacitors and the presence of the resistors in the circuit make the transistors to get biased properly. So once it will be done, the amplifications of the signals task will become efficient and simpler.
Good day, Mom. I'm Galit and I'm here to discuss about oscillators. What is an oscillator? An oscillator is a circuit which produces a continuous, repeated, alternating waveform without any input. Oscillators basically current and directional current flow from a DC source into alternating waveform which is of the desired frequency as decided by its circuit components. Oscillators is a mechanical or electronic device that works on the principles of oscillations, a periodic fluctuations between two things based in changes in energy, computers, clocks, watch, radios, and metal detectors are among the many devices that use oscillators. However, by then the stored electromagnetic field would have generated a back EMF which results in the flow of current through the circuit in the same direction as that of before. However, the oscillations which arise due to the interconversions between the two energy forms cannot continue forever as they would be subjected to the effect of energy loss due to the resistance of the circuit. Nevertheless, it is to be noted that the energy supply should be precisely controlled and must be equal to the energy lost in order to obtain the oscillations which constant amplitude. Practically, the oscillators are nothing but the amplifier circuits which are provided with a positive or generative feedback wherein a part of the output signal is feedback to the input. Here the amplifier consists of amplifying active elements which can be a resistor or an OP, EMP, and the backfeed in phase signal is held responsible to keep up the oscillations by making up for the losses in the circuit. Once the power supply is switched on, the oscillations will be initiated in the system due to the electronic noise present in it. Types of oscillator. There are many types of oscillators but can broadly be classified into two main categories, harmonic oscillators and relaxation oscillators. In harmonic oscillators, the energy flow is always from the active components to the passive components and the frequency of oscillation is decided with a feedback path. Whereas in relaxation oscillators, the energy is exchanged between the active and the passive components and the frequency of oscillators is determined by the charging and discharging time constants involved in the process. Further, harmonic oscillators produce low distorted sine wave outputs while the relaxation oscillators generate The main types of oscillators include Wien bridge oscillators, RC phase shift oscillators, Hartley oscillators, voltage-controlled oscillators, Colpitts oscillators, clock oscillators, crystal oscillators, Armstrong oscillators, tone collector oscillators, gun oscillators, cross-coupled oscillators, ring oscillators, Denatron oscillators, Meissner oscillators, optoelectronic oscillators, Pierce oscillators, Robinson oscillators, treated oscillators, Person-Anson oscillators, delay line oscillators, Royer oscillators, electron-coupled oscillators, multi-wave oscillators. Oscillators can also be classified into various types depending on the parameter considered, i.e., based on the feedback mechanism, the shape of the output waveform, etc. These classification types have been given below. Number 1. Classification based on the feedback mechanism, positive feedback oscillators and negative feedback oscillators. Number 2. Classification based on the shape of the output waveform, sine wave oscillators, square or rectangular wave oscillators, sweep oscillators, and etc. Number 3. Classification based on the frequency of the output signal, low frequency oscillators, audio oscillators, radio frequency oscillators, high frequency oscillators, very high frequency oscillators, ultra high frequency oscillators, and etc. Number 4. Classification based on the type of frequency control used, RC oscillators, LC oscillators, crystal oscillators, and etc. Number 5. Classification based on the nature of the frequency of output waveform, fixed frequency oscillators, and variable or tunable frequency oscillators. Oscillator applications. Oscillators are a cheap and easy way to generate a specific frequency of a signal. For example, an RC oscillator is used to generate a low frequency signal, and LC oscillator is used to generate a high frequency signal, and an OP EMP based oscillator is used to generate a stable frequency. The frequency of oscillations can be varied by varying the component value with potentiometer arrangements. Some common applications of oscillators include quartz watches, used in various audio systems and video systems, used in various radio, TV, and other communication devices, used in computer metal detectors, stun guns, inverters, ultrasonic and radio frequency application, used to generate clock pulse for microprocessors and microcontrollers, used in alarms and buzzes, used in metal detectors, stun gun, inverters, and ultrasonic, used to operate decorative